For thousands of years, humanity has looked up at the night sky and asked the same question. Are we alone? Every civilization that studied the stars eventually wondered whether life exists beyond Earth. Ancient philosophers imagined other worlds. Scientists developed theories. Writers created stories about distant civilizations hidden among the stars. Yet despite centuries of curiosity, we had no evidence that life existed anywhere except our own planet. Now, that may be beginning to change. Far beyond our solar system, orbiting a faint red star approximately 120 light-years from Earth, a distant world has emerged as one of the most intriguing places ever discovered. Its name is K218b. At first glance, it doesn't look particularly special. It is not a twin of Earth. It does not orbit a star like our Sun. In fact, it belongs to a completely different category of planet, one that scientists once considered unlikely to support life. But recent observations have forced researchers to take a closer look. And what they found has sparked one of the most fascinating debates in modern astronomy. The story begins with the James Webb Space Telescope, humanity's most powerful observatory ever sent into space. Unlike traditional telescopes that primarily observe visible light, Webb specializes in infrared light. This allows it to study distant planets with extraordinary precision. When a planet passes in front of its star, a tiny fraction of starlight travels through the planet's atmosphere before reaching the telescope. Different gases absorb different wavelengths of light. By analyzing those missing wavelengths, scientists can determine what chemicals exist in an atmosphere hundreds of trillions of kilometers away. It is an astonishing achievement. Without ever visiting these worlds, humanity can investigate their atmospheric composition from across the galaxy. When researchers examined K218b using this technique, they discovered something remarkable. The atmosphere appeared to contain water vapor, methane, and carbon dioxide. Individually, none of these chemicals prove the existence of life. But together they paint a picture of a world that may possess the conditions necessary for complex chemistry. Then came the most intriguing possibility. Scientists identified evidence suggesting the presence of dimethyl sulfide, often abbreviated as DMS. On Earth, this molecule is produced primarily by living organisms, especially microscopic marine life. That immediately attracted attention. If DMS truly exists in the atmosphere of K218b, researchers must explain how it is being produced. However, science demands caution. Extraordinary claims require extraordinary evidence. The potential detection remains under investigation, and scientists are actively collecting more data to verify the signal. No responsible researcher is claiming that alien life has been confirmed. But the possibility is significant enough that astronomers around the world are paying close attention. What makes K218b particularly fascinating is its unusual nature. The planet is much larger than Earth. Its mass is several times greater, and it appears to possess a thick atmosphere dominated by hydrogen. For many years, planets like this were largely ignored in the search for life. Researchers focused instead on rocky Earth-like worlds. The reasoning seemed obvious. Since life emerged on Earth, perhaps similar conditions are required elsewhere. But nature rarely follows human assumptions. Recent theoretical studies suggest that certain hydrogen-rich planets could maintain surprisingly stable environments. Beneath their atmospheres may exist enormous global oceans. These oceans could remain liquid for billions of years. If true, such worlds would provide vast environments where chemistry could evolve and become increasingly complex over time. Some scientists have proposed that K218b may belong to a class of planets known as Hycean worlds, a term combining the words hydrogen and ocean. These hypothetical planets are thought to possess deep oceans beneath hydrogen-rich atmospheres. If they exist in large numbers, they could dramatically expand the number of potentially habitable worlds in the galaxy. Imagine an ocean planet unlike anything found in our solar system. Not continents separated by shallow seas, not small islands surrounded by water. Instead, imagine a world where oceans dominate the planet on a global scale. A world covered by vast layers of water stretching far beyond the deepest trenches on Earth. Such an environment could support entirely different forms of chemistry and potentially entirely different forms of life. Energy might come not only from sunlight but also from interactions between water, minerals, and internal planetary heat. On Earth, life thrives in some of the most extreme environments imaginable. Microorganisms survive near volcanic vents on the ocean floor. Others endure crushing pressures deep beneath the surface. Some even live in highly acidic environments that were once thought impossible for biology. These discoveries taught scientists an important lesson. Life is often more adaptable than expected. Because of this, researchers have become increasingly cautious about declaring any environment uninhabitable. K218b represents that lesson on a cosmic scale. The planet challenges our assumptions about where biology might emerge and persist. Perhaps the most profound implication has little to do with one specific world. Instead, it concerns the broader question of how common life may be throughout the universe. For decades, scientists searched primarily for planets that closely resembled Earth. But what if Earth is not the only successful blueprint? What if life can emerge under a wide variety of conditions? What if stable oceans, active chemistry, and sufficient time are more important than exact similarity to our planet? If that idea is correct, the number of potentially habitable worlds could increase dramatically. The Milky Way contains hundreds of billions of stars. Many of those stars host planetary systems. Even if only a small fraction possess suitable environments, the number of potentially life-supporting worlds could be enormous. Another factor makes K218b especially intriguing. Its star is a red dwarf. These stars burn fuel far more slowly than stars like our Sun. While the Sun is expected to remain stable for roughly 10 billion years, many red dwarfs could survive for trillions of years. That means planetary environments around such stars may remain stable for extraordinarily long periods. If life emerges there, it could have vast amounts of time to evolve. On Earth, complex life required billions of years to develop. Imagine what evolution might accomplish given far longer timescales. Could ecosystems become more complex? Could intelligence emerge? Could entirely unfamiliar biological systems develop under conditions unlike anything we know? At present, no one can answer those questions. But discoveries like K218b make them increasingly difficult to ignore. The search for life has entered a new era. For the first time in history, humanity possesses instruments capable of analyzing the atmospheres of distant worlds in extraordinary detail. Future observations will provide clearer answers. Scientists will continue studying K218b and many other planets. Some promising signals may disappear under closer examination. Others may become stronger. That is how science advances. Each observation adds another piece to a much larger puzzle. And regardless of what future data reveals, one fact is already clear. The universe is far more diverse than we once imagined. Worlds exist that challenge our expectations. Planets exist that do not fit neatly into familiar categories. And somewhere among those countless worlds, life may already be flourishing. Perhaps not life exactly like ours. Perhaps not civilizations building cities and spacecraft. But life nonetheless. The discovery of K218b has not proven that humanity is no longer alone. What it has done is perhaps even more important. It has shown that the possibility is real enough to investigate seriously. For centuries, the question of life beyond Earth belonged largely to philosophy and speculation. Today, it belongs to observation and evidence. The answer may still be years away. But for the first time, humanity is beginning to see worlds where that answer might be waiting. And somewhere in the darkness between the stars, a distant planet continues orbiting its faint red sun, carrying secrets that could forever change our understanding of life in the universe.